Pesticides are vital to many aspects of modern life. They're used in farming, forestry, land management, and in domestic settings. There are 5 types we commonly find being used. Insecticides control troublesome insects. Herbicides kill weeds and keeps other unwanted vegetation in check. Fungicides prevent mold and mildew from forming. Disinfectants prevent the growth of bacteria. And growth regulators help to optimize agricultural yields. Used and managed correctly, they play a vital role in protecting public health and our environment. But used incorrectly or managed poorly, they do an equally good job at destroying both. Pesticides can harm more than just the pest they are targeted at. They can be toxic and cause a number of negative health effects, from skin irritation to respiratory problems and even cancer. And when incorrectly managed, they can cause irreparable damage to local biodiversity. Correct use and management doesn't stop once the pesticide has been applied. The containers they came in pose just as much a threat and need to be disposed of in a safe manner. They may appear empty, but will almost certainly contain residue, often in highly concentrated form, that needs to be carefully dealt with using a process called environmentally sound management, or ESM for short. Almost all pesticides used across the Caribbean are imported. This means that there is a constant inflow of containers that might have the potential to cause great harm if stockpiled or improperly disposed of. Knowing how many containers there are in a country, what they contained, what they're made of, and where they are is both vital and useful. Vital because it's possible to identify potential sites of hazard that require attention, as well as highlight where new or adapted legislation is required to offer further protection. Useful because it's then possible to consider and implement the steps necessary to enable the safe reuse or recycling of the containers. The BCRC Caribbean is one of the 14 regional centers around the world for the implementation of the Basel Convention, which monitors and controls the cross-boundary movement of hazardous waste, including pesticides. In 2019, they introduced a trial in Belize with the aim of establishing a national inventory for waste pesticide containers. This provided some very useful insights, and they are now introducing the same in Guyana, Antigua, and Barbuda. The hope is that the same approach is used in other nations across the Caribbean. So what's involved in establishing a national inventory of waste pesticide containers? Let's take a look. First, there needs to be clarity and understanding of its purpose. For example, a priority aim might be to inform policy decisions on waste management, or there may be the need to consider increasing capacity of local recycling facilities to accept these types of containers. So knowing how many they can expect will be needed to support these aims. What's been found so far is that there's several factors restricting the ESM of waste pesticide containers. There's very few collection centers. Weak enforcement mechanisms prevail, and a lack of extended producer responsibility. All these things can be addressed but do require investment and political will. And to achieve these requires robust evidence and data. So, creating an inventory is a vital first step in the process of reform. But, regardless of the regional objectives, one commonality must apply, and that's the need to align the inventory with the national reporting requirements that relate to the Basel Convention. If you're not familiar with this, there's a video you can watch and you'll find the link below. The next step is to consider how far and wide the inventory will go. As we saw a moment ago, pesticide use is very wide-ranging from farms to homes. As good as it would be to accommodate all types of use, it would be impractical or impossible to accurately account for something like domestic use. Farming is of course likely to feature strongly, but not everywhere. Tourism and hospitality sectors may well be dominant sectors in some regions, so land management and horticulture would feature more strongly here. The key is to speak to local stakeholders and ascertain the priority activities that need to be included. This will also inform the locations to look at, the types of containers that are likely to be present, and the time period over which the inventory can cover. The project in Belize revealed a range of stakeholders that need to be engaged when developing inventories. Firstly, it's necessary to know how many containers are coming into and leaving the country. The National Pesticide Control Board will be a primary source of this information, but importers and exporters should also be spoken to. Next, we need to know how many are sold. This tells us how long pesticide products remain in stock and identify the number of containers in use at any one point in time. So, wholesalers, retailers, and distributors need to be approached. Then there's the users of the pesticide products: farmers, land managers, horticulturists, pest controllers, cleaning firms, and so on. Asking them to do this requires that they add another process to their already busy lives, something that they may not be willing to do, and some may well be undertaking practices that they'd rather not publicize. Rinsing, burning, and burying containers is a common practice in some parts of the Caribbean. We've also found that non-compliance with the best environmental practice is most prevalent in remote areas. So when considering the sample areas you focus on, don't just look at the areas close to the towns. Public health officials can also be a useful source of information. For example, if local clinics or hospitals report having to deal with high levels of conditions related to pesticide exposure, this may indicate pockets of problems in some areas. And finally, waste management companies. Knowing the number and type of waste pesticide containers that make it this far tells you how many are still out there. Data for first-generation inventories is drawn from two types of resource. The first type are national authorities such as the Pesticide Control Board and customs departments. The data can also be cross-checked with the data on platforms such as the Hazardous system or UN Comtrade. But this will only tell you what's come into the country. We need to understand what happens after they've arrived, and this means engaging directly with wholesalers and users. Questionnaires can be used, and field visits give you the opportunity to see firsthand how containers are being used and dealt with. And it's perfectly acceptable to visit a sample of sites rather than every farm, hotel, and gardener. Though, of course, if you have the resources to do this, you'll get a super accurate inventory. We can now get into the process of quantifying the containers. The trial in Belize identified 8 types of containers that are commonly used to ship and store pesticides. They are intermediate bulk container, sometimes referred to as a tote, 55-gallon drums, both metal and plastic, 5-gallon drums, 20-liter containers, 30-liter containers, plastic bag and plastic containers ranging from 100 milliliters to 750 milliliters. It's important to record the material the containers are made from, as this indicates things like recyclability, perishability, reuse opportunity, and so on. The data you gather can then be entered into a database, as you see here. Enter the date the assessment took place, the name of the assessor, where it took place, the site code is the country number determined by the Basel Convention, what type of pesticide the container was for, the type of container, what condition the container was in, and its size or capacity. You'll see there's two more columns for the weight of the container, and determining this is the next step. There's three ways to determine the weight of the container. You can do some desktop research and find the specification sheet from the container's manufacturer or shipping documents. You can take sample weights in the field, or you can use these as proxy weights. These were established during the trial in Belize and provide a good standard weight for each type of container. The number of units of pesticide containers imported each year can be obtained from the pesticide control boards, and you need to apply this calculation to the figures. For the next step, it's a return to what by now I think it's safe to say your good friends at the Pesticide Control Board. We need to determine the number of pesticide containers that are exported. So, if they regulate licenses for pesticides in your country, then that will be able to provide you with this data. And for each type of container, this calculation must be applied. In some countries, there may not be reliable data on the number of containers exported if the export of pesticides is not regulated by the Pesticide Control Board. In this case, it may be possible to obtain this data from the Customs or the UN Comtrade platform. However, it might be difficult to obtain data for the type of container exported. And as some countries do not manufacture, reformulate, or repackage pesticides for export, the number of pesticide containers which leave the country via formal mechanisms can likely be considered negligible. In this case, the number of exported containers can be assumed to be 0. To calculate the tons of pesticide containers in use for a particular year, simply apply this formula. The useful life factor tells us how long a container will or could be used for its intended purpose, that is, to store pesticide. We need to determine this for each type of container that's used. This information can be got from farmers' associations or other statutory agencies via questionnaires or field visits. For example, farmers may indicate that pesticides stored in 55-gallon drums are used over a 2-year period, while sachets may be used within a year. The ULF will be the inverse of the average lifespan. In cases where stakeholders do not record the data, all pesticide imported within a given year can be assumed to be used within that same year. Therefore, all pesticide containers imported during that year become waste pesticide containers in that same year and have a lifespan of 1 year. We do know that this assumption may lead to an overestimation as some pesticides may remain in storage. So the difficulties in obtaining data on the number of pesticide containers still in use versus the number which have not yet become waste should be noted. We can now work out the ton of waste pesticide containers for each container type. We can also calculate the total tonnage generated per year by applying this calculation. We're working on the standard assumption that containers are being used within 12 months of them arriving in the country. Whilst this simplifies the calculation, it can lead to inaccuracies, and you will likely find the process hampered by the lack of record keeping amongst farmers and other stakeholders. So it's necessary to apply some final steps to refine the inventory and dial out many of the inaccuracies possible. Conducting interviews with a sample of users can be of great help. Much of the insight will be anecdotal, so talking to people will help to clarify and verify. You can apply stochastic modeling. This is a method that uses random variables to predict statistical properties of possible outcomes whilst accounting for random variations. And if you're only able to obtain data from a small number of regions, you can apply national estimates and do some extrapolation. You then need to define and assess the collection potential. In other words, how feasible is it to collect waste pesticide containers and properly dispose or recycle them? There's 5 factors to consider: the number of containers to enter the market each year, the practical challenges of collecting them, the accessibility of where they are kept, the cost of collection, and so on. Some users or even communities may not welcome their removal. How can this be overcome? What level of policy enforcement will be required, and what level of political support can be expected for this? What is required to raise awareness, and how much will this cost? Determining this will require further stakeholder consultation and the analysis of the transportation and communication systems that are accessible in the region. You can then model a collection scenario. A minimal collection scenario describes how you might access existing systems at no or minimal additional cost. A moderate scenario introduces some modest infrastructure improvement, perhaps some collection centers, collection vehicles, and the like. And an optimal scenario sees the implementation of a comprehensive program of measures, awareness campaigns, financial incentives, enforcement policies, and more. The final step is the inventory report. 5 sections are needed: the quantitative findings, risk assessments, mapping, showing where containers are being accumulated, recommendations for the implementation of environmentally sound management of the containers, and national action plans needed for container management. And that's how you create an inventory of waste pesticide containers. Don't forget that the BCRC team are here to help you along the way, and check out the links for further resources you'll find below. Thanks for watching.